Okay, so this is our second to last lesson for this unit. It is kind of just a refresher about function notation, except now instead of doing it with only linear and absolute value functions, we can do it with quadratic functions as well. So in case you've forgotten, we've got questions where I'll ask you what's f of 4, or separately find x if f of x is 2. And the hard part about that is just remembering, did I give you x or did I give you y? So in this first one, the x is gone out of the f of x, so I must have given you x and want you to find y. Whereas in the second problem, I'm telling you that y is 2 and I want to find x. Same thing in this guy. Y is now 10 and I want you to find the x that causes that. And if you remember back from when we did this in the first unit, we can do it from the graph or we can do it from the equation. I'm going to go ahead and make the graph so that we can look at it. All right, so this is a quadratic in function form, in vertex form. Vertex is -3, 8. Let me go ahead and plot that, -3, 8. Our first stair step size is -2, and then we know that our rate of change is changing by 4, -4. So if this was down 2, 4 more than that would be 6, 4 more than that would be 10. So that puts us here and here, and then down 10 would put me here and here. So there's my quadratic. So let's go ahead and, oh, I totally missed. Let's try again. There and there-ish. All right, let's go ahead and answer these questions then. Since we have the graph, we might as well see if we can find the ordered pair where that happens. So if I look at my graph for, let's see, I'm asking for f of 4. So that's when x is 4. That's all the way over here. I know it's going to be down there somewhere, right? Because that quadratic is going out for forever, so it'll get there somewhere. But we can't see it on the graph, so we have to use the equation. So remember, if I've said f of 4, x is 4, so we just need to plug in, leave y, plug in for x, and go ahead and work that out. So if we did that, we'd have 7 plus 8, then square that, so 49, double that, -98, and then plus 8 would put us at -90. So we know that the rest of that ordered pair that started with 4 would be -90, and hopefully you haven't forgotten that is f of 4 equals -90, right? And that makes sense. We know that we're way down there on our graph when we finally get out to 4. Okay, let's try again with find x if f of x is 2. That means we need ordered pairs whose y value is 2. So you can see that that is going to happen on our graph. It's going to happen here and here, but they're not pretty values. So again, our only option then is to use our equation. Except now I've given you y, so you'll plug that in for y, right? And then keep your x. So if we solve that, we'd subtract the 8 over. Since x is in only one place, I'll just make a note of this. We're going to do the square root method since x is only in one place, so we'll get x by itself. Subtract the 8 over, we get -6. Right, and then divide by the -3, we get 2. And then square root both sides, so we have the square root of 2, always plus or minus when we square root, right? And then to finish this out, we'd subtract the 3 over, so we'd have a -3 plus or minus root 2 equals x. So we know that the spots that those are really crossing at 2 would be -3 plus root 2, comma 2, and then separately -3 minus root 2, comma 2. And if we wrote that in function notation, we'd be saying that f of -3, just to save time, plus or minus 2 equals 2 when we plug those guys in. I know that looks ugly, but it's true. All right, one more. Okay, this last one, we want to know where y is 10. So if you look at your graph, up here when y is 10, previously we would have said, that's a no solution. But we know that no solution no longer exists for us in quadratics. That just means it's an imaginary solution. So let's see what that imaginary solution is. Again, we have to use the equation. So 10 for y, negative 2, x plus 3 squared plus 8. Subtract the 8 over, we'd get a 2. So again, I'm doing square root method. Divide the negative 2, we get a negative 1. Square root both sides, so then we've got plus minus root negative 1. And there's our imaginary, right? Since we previously could not square root negatives, but now we know that that just means the square root of negative 1 is I. Last step would be to subtract the 3 over, so we have negative 3 plus or minus I equals x, right? And we could write that in function notation also, that f of x is negative 3 plus or minus I. When we plug that in, we should get out 10, right? And I know that feels weird, but for real, if we plug that back in to the equation and for x and square it all out, the i's would go away and we'd be left with just plain 10. Okay, so that was basic function notation. Same stuff from last unit, just doing it with quadratics. And then we have some operations with functions. So if I give you a choice between 3 functions, could you add and subtract them, multiply them, dividing we say for next year or next semester, and then function composition, g of f of x. So let's make sure we're comfortable with this stuff. So if I ask you to take function f and from it subtract function g, that would be me asking you to take f is 5x minus 1, and from it I want you to subtract x squared plus 3x minus 10. So if we, adding and subtracting, remember when we do that we're just combine like terms. That's what adding and subtracting is, right? So I've got, in this first one, I'm going to kind of change this first one so it looks quadratic, just so I have like terms. I'm going to make this a, let's see if I can move this over. There we go. I'm going to make this a 0x squared, and then there's that positive 5. So that I know that I'm going 0x squared minus 1x squared, so that's negative 1x squared. Then 5x minus 3x is positive 2x. And then finally, negative 1 minus negative 10. Negative 1 minus negative 10 is really negative 1 plus 10, so 9. So we know that f of x minus g of x is the new function, negative 1x squared plus 2x plus 9. Remember when we do function operations, we don't get a set answer, we just get a new function. That one happens to still be quadratic. Okay, the middle one says take f of x times g of x. So f of x is 5x minus 1, and we want to multiply that by g of x, which is x squared plus 3x minus 10. Okay, so to multiply things out like this, we have to distribute the 5 to all 3 things, the 5x, then the negative 1 to all 3 things. So 5x times x squared, that's actually going to be, I'm going to go green, 5x, we would have an x and then 2 x's, so 5x cubed. That'll be the focus of our next unit, by the way. Then 5x times 3x is 15x squared. 5x times negative 10 would be negative 50x. Then the negative 1 times each thing. We would have negative 1x squared, negative 3x, positive 10. Combine our like terms. Let's see, like quadratics right there. And separately like linear pieces right there. So we would have 5x to the third. Quadratic pieces end up being 14x squared overall. Linear pieces end up being negative 53. And then positive 10. And that is f of x times g of x. And we got actually a cubic function. Like I said, we'll be coming to that in our next unit. Okay, so you can multiply functions together, you can add and subtract them, and then this last one was function composition. Remember, this says to put f 5x minus 1 inside of g. So it's going to go in place of this x, and it's going to go in place of that x. So let's see what that looks like. I'm actually going to come straight down from here, so I have a little bit more space. Okay, so g of x was x squared plus 3x minus 10, but now I know I'm going to take out the x's and put f of x in place of there. And f of x was 5x minus 1, right? And then I'll have to simplify this. So off to the side here, I'm going to go ahead and do that 5x minus 1 squared. I know that means to write it twice and multiply it out. So if I do that, here's what I've got. So 25x squared minus 10x plus 1. All right, so that's going to be in place of this. 25x squared minus 10x plus 1. I can go ahead and distribute this 3 since there isn't a squared on that parentheses. So that's a plus 15x and a minus 3. And I still have that minus 10 at the end. So let's combine our like terms. There's a linear and a linear. I've got a constant, and a constant to combine. Overall, though, we have 25x squared plus 5x minus 12. And that is my f of g of x. Putting g, wait, did I write that backwards? Yes, I did. Let's fix that. There we go. G of f of x, so putting f inside of g. Okay, so this is not new stuff, it's just doing it with quadratics. Same stuff as old stuff. So I'll post the worksheet, you can get working on that very, very soon.